at the top. So let's see if we're recording. Okay, it says recording begins in 10 seconds. It gave me a 10-second stop, and then it started recording, and then it said press Q to stop. Okay. So what I'm going to do now is give you a quick overview of how good this looks, which you can see from my friend's website about Linux audio recording, and his main site, which is coming up right this second. Yep. That's supposed to look like that. That's supposed, you see by, I don't know if it's recording the mouse. That's supposed to look pixelated out because he's been working on pixelation. And let's see if he's got a really cool, he's got a cool site with animation, although I see some animation. This is recording his other site, and it plays sound, but I just want to see if it actually is recording what you can change music. That's actually a cool thing. How cool is that? That's super cool. All right, and he's got a little thing here. If you click on this, something happens. I don't know. He's got all this cool stuff going on. Okay. Let's go back to where I was at before. Anyway, so this is my big time screen recorder. But what I'm going to do now is really super boring. But I'm going to go through the program itself. Which is called nutrecordx.bash. Cmax is basically Emacs with out the GUI. I suppose I could use the GUI, but it's easier to read without it. Let's see. Alias Cmax equals Emacs no windows, you see. If you can read that. Okay. So Cmax nutrecordx.bash. I'll come up with a better name for it later. Okay. It's a bash script. It's an interactive bash script. So it starts off with bash, record screen at full resolution with audio, MP4 format, H.264 video, AAC 256 kilobits per second audio. I start off with some flags. Some of these aren't even used. They're just so humans can look and see what I'm doing. Use shared memory equals 1 is yes. These are flags. All these other flags are empty. Compression equals 0. I'm not using any compression on the video when I'm recording it. It compresses itself on the final mux. Compression must be lossless to do any video processing, otherwise the quality suffers exponentially. So I'm starting at 0. FFmpeg does well with speed if audio and video are output to several files. So what I'm doing is I'm going to be outputting the audio uncompressed and the video losslessly to separate files. And I'm using, for storage of the intermediate files, I'm using the NUT container, which is an FFmpeg container, which is designed to be robust and maintain sync and can take many different kinds of formats of audio and video and understand it. But some people don't like it because it's it's kind of specific for FFmpeg. But you can create H.264 files for raw and X264 video, H.264 video, if you wanted to. But you'd have to change the script. So here's some temp files, and they're audio files and video files, A1, A2, and A3. A1 is what is the raw wave, A2 is audio filtered, and A3 is the compressed AAC format, advanced audio codec. And then video 1 is the main video that's being captured from the screen. The filtered video would be cleaned up or sharpened, and the resized video is if you want to resize the video. In this case, I'm not doing it. I'm at the full resolution of my monitor, which is 1920 by 1080. Okay, now for speed we use device shared memory for temp files. In this case, I've got plenty of memory. I have a 4 gig machine, and it uses 2 gigs by default when you set it up. However, it doesn't really use that memory unless it needs it. Okay, and if you ever exceed it, it will go into swap. It will swap it out, which would not be good for this application, but it keeps the machine from crashing. However, there are 2 different conventions now. If you're on Ubuntu, they've remounted all the temp stuff into the /run directory. So /run, there is a symlink to dev shm if you're on other Linux. Other Linux mounted on dev shm, so we check and see one or the other. And if neither one of those exist, then we use the present working directory. Okay, we use xdpy-info to get the screen resolution, and then we just grep the dimensions line out of it and get the use awk to get the actual thing, which is actually a string that says 1920 by 1080. And by default, we set our output size to be our input size. And by default, we use the local X display that we're looking at, display 0. Okay, we save our current directory into a variable curdir. We change our working directory to our shared directory. And then we clean up any old files, any .NET files. Okay, now here's some utils that I use. Here's a little function in Bash to generate a countdown. And this line here, which says if start equals start, looks redundant, but it isn't. What it does is it takes you'd think it would always equal, but it wouldn't be. That means it has to be a number. It has to be able to the equal function will fail if it can't turn start into a number. In other words, you send it a string that looks like a number. In this case, we use 10, and then it'll bail because you sent it something wrong. Okay, and it says, and then it will say recording begins in how many seconds, and then it runs a little countdown with the Bash's C style notation, like a for loop in C. Works real good. It just prints it out, and then when it's done, it's done. Okay, here's our usage. Tell the user how to invoke the program. Usage is just a help file. And these are the options that you can have. You can have countdown, you can show the help, you can keep your temp files at the end of the run. P, you can tune for pictures, which is film. I hit the microphone, I hope it didn't make a noise. Normal, but I actually tuned it for animation on this case because I consider screen graphics, Windows screen graphics animation. However, I've tried both of them. I haven't really seen the difference. -s, which takes a size string, and you can use the standard things. You can use HD 720, HD 480, SVGH, or a string of width times height with ints, and it defaults to whatever resolution you're actually using with the XDPY above. Q, no audio record. Just record the video. Don't record this audio while you're at it. V, verbose, which prints out a bunch of junk which shows you what it's doing. X, do not post-process, which doesn't add the audio or video filters. And then I'm using the getOps, and I'm making it real simple. getOps, I'm just setting flags with getOps, except for S, and that says outsize equals optarg. And So when you have an option with getOps, the argument of the option is called optarg. Okay. All right, no verbose or not, just sets them. And then this little line, which I had to find on the in the back alleys of the internet, basically shifts the argument list past all the arguments to the output file. Now, what if I don't give an output file? Well, we have a default output file, which is actually which is the date with an MP4 extension, and then it just I get the current date and time, and then echo it to the screen, and then set the out file variable to that. Otherwise, this is the old convention where if argument 1 is blank, if x argument 1 equals x nothing, then that's the way to do string matching in a simple way. There might be a better way. All right, and since I'm using dates clear to the minute, every time if you happen to run this thing backward, one right and then bail and then run it in the same minute, so it would be the same name file, it moves it to old. Okay, now we're into our setup, which first of all is we clear the screen with tput, which I think is pretty universal. Echo the title of the program. Then we check and check our flags and then do stuff. If their countdown is true, we run the countdown. If pictures is true, we tune to film. Otherwise, we tune to animation. If verbose, our log level is info, and otherwise our log level is error, which only outputs to the screen if something bad happens. Okay, and then we say at recording, press Q to stop. And okay, now if silent, that means that we decided not to record with any sound. So we begin recording, and okay, so we say FFmpeg log level info, overwrite files is yes. Use the X11 grab a window of size, and then from our display, which is 0, change the pixel format to a normal pixel format for MP4, which is YUV 420p, which actually is a reduced color format, and it's faster that way. I think that native RGB is 32-bit, whereas in this case this uses a compressed color format. Using AN, no audio, right? This is silent. X24, and then the compression, CRF is the compression factor, and that's 0. And then we're tuning for animation, and we're using the preset ultra fast, which is a preset which modifies the encoder, and we're using thread 0, which means use all available threads. It's smart enough to use all of it. And then we're outputting in NUT format, and we're using output to V1, which remember was video.NUT. Okay, that's if silent, which is not the default. Otherwise, this is the default. And you'll see that we're using one program, FFmpeg, but we're using two outputs. We're using the ALSA input pulse, because this is a Ubuntu system and it uses pulse audio in ALSA format, 2-channel ALSA format. I have a surround sound 5.1 system, but I'm recording through the microphone in stereo. So I'm telling it that it's got 2 audio channels. Audio channel sole input is from pulse, which means the pulse audio. Output is to NUT, which I did have it out as a wave before, but I decided just to make it NUT consistency. This is NUT record. Out to audio 1, which was audio, and then this is the rest of it's all the same. You see, this one. So it sets up 2 threads. FFmpeg sets up 2 separate threads, one for audio and one for video, and puts them out to separate files. in/run/shm. Now, if I switch over here to, give me a new tab. All right. If I switch over to and go there and look at some files, you'll see that Pulse uses it, and some of these other things uses it. I don't even know what CAPI20 is, but my two programs right here are NUT files, and you see if I hit it again, you'll see that they are getting bigger. That's what they're adding. Yeah, okay, we can look at now in human terms. You can see that they're not that big. They're not that big. And if you look at how much money I've got, you see, it says I've got, a 2 gig size. So it's recording files in shared memory, not on the disk. So I'm avoiding disk writes because I'm recording in real time. Okay, this is still doing there. I'm getting no errors. Okay. Okay, so now that's where it records. And then when it's done, I hit Q and it'll say recording finished. And then if I had said don't do any processing, then what we do is we check to make sure the files are there. And then we take the inputs in NUT format, V1 audio, A1 audio, and set the pixel formats, and then we copy the video straight because we're recording it up here with LibX264, but now we encode the audio with a live FDK AAC at 256K bits per second, 2 channels, and we add the ADTS to ASC bitstream filter to realign the most significant bits, least significant bits, and header formats to the proper ASC format from the ADTS format. There are some applications that want ADTS and some that want ASC that are both, or that can figure out both, but this makes it all work. And then we create the out file. Otherwise, if we see here, if we have A1, otherwise, if the audio file doesn't exist, we just create the video file. Keep going down. All right. Now, else down here is we are using post-processing. So we start off with the audio processing, and we want to clean up the audio. And then we say if the audio file exists, obviously, and then we echo out, and then we're using LADSPA filters. I've got 3 of them. I have an expander, a compressor, and a limiter. And then here is a using the LADSPA caps library, which is a very famous library for guitar effects. But they also have a 10-band equalizer. And if you see that what it is, how it works, is the string is LADSPA equals file equals CMT Carnegie Mellon, expand RMS filter, and then it's got 4 settings, 0 through 3, and then compress RMS filter, 0 through 3, and then here's the limit filter, 0 through 2. And the caps filter is a 10-band filter. And I'm using that because of this microphone. I try to get the ambient noise out. Okay. And so we start with noise reduction. We use the noise reduction filter, which is expander and compander and a limiter, and right through the thing, and then we output it here. Our audio encoder is the same audio encoder that we had before, PCM S16LE, which is wave format, Microsoft wave format, and output it to NUT and call it A2, which, if you remember from the top, Going back up here, A2, well, where is it? A2 is FFmpFilteredAudio.NUT. A3 is FFmpac.NUT. Okay, come back down where we were. Okay, so we do the compressor and put it in, and then we take that, and then we take in A2 as an input, and then run it through our AAC compiler encoder, and output it to A3, which is the AAC.NUT. Okay, well now, here's the same. We do the same basic thing with the video, only we do it because we have separate files. I'm using, there's Unsharp and Smart Blur to sharpen it up. And I'm trying both of them. Unsharp looks really good, but is very slow. Smart Blur looks okay and is much faster. Right now, you can see that I have the Smart Blur. I'm not using it. But the Unsharp I am using. Video filter, Unsharp. And then my convention is just to, put the whole thing into one little thing and then let Bash expand it. Okay, and that outputs to V2. And then here's a little trick to make things easier. Since I created V2, now I no longer need V1, so I just assign V1 to V2 as a variable. It makes it easier to reuse the code below. Okay, now then we check to see if our output size variable and our original size variable are different. And if they are, that means we want to resize the video. So what I do is I'm using the size filter, and it's basically the same, and it's just changing the size, and it changes it, outputs that size video to V3. And then I take V2 because this has already been through here, right? Output is V2. We input V1. But see, I changed V2 to V1, so V1 is the same. In case there isn't, see. And then, since there's a V3, I assign V1 to the name of V3, because down below here, okay, else, there's no, if it was a lossy, get ahead of myself. If we did use compression on the initial capture, it looks terrible if you try to apply filters. So then that's what happens there. Okay, now we're all done with all processing. Now we need to stitch the two files together. Okay, if V1 is found and if A3 is found, then we mux the audio, and you see that we take in the two NUT files, V1 and A3, and we just we don't do anything to them. We just take them and copy them without encoding them. Make sure that that's happening. This BSF filter, even if it's already applied twice, it doesn't do anything. And then to the out file. Otherwise, if the audio file doesn't exist, we just do the video through a copy. All right. And then if keep temp files is true, which it should not be generally, now that I've got everything working, we just remove all the temp files that start with FFm_. And then when we're finally done, we take our output file from our temp driver and move it into our current directory, and then we're finished. And so you're looking at it and you're listening to it. The whole thing took me nearly a week, and it's an 8K file. And there's a difference between the two. That's an older one. So I've got to find a better name for it and see how it works. And you can't really see what it's going to do next, but it's just going to print out print out those echo things. I'm going to hit Q now, and we're going to be done with it. I'm going to figure out a way to capture that. All right, so I didn't get to show you until the end here that this has actually helped the entire run of it. It took a while. It said press Q to stop, and then when I pressed Q, it printed out recording finished, and it started audio filtering. noise reduction, compressing, and that took longer than I thought, and then it went to video filtering, sharpening, and that took a hell of a long time. Strangely, almost as long as it took to record this whole video. And then in the end, it didn't take very long. Muxing audio video took like 3 seconds, 5 to 10 seconds, and then it was done. And so that's as far as I've gotten so far. And you see that the output file that it did create was Screencast, and then the month, day, year, and then the time. And in this case, it's 90 megs, plus a little extra for this.